Hi, hello students. In this video, we are going to discuss one more important numerical which was asked in the Cbse board exam previous years. A very important numerical. I am sure you would have seen this numerical in your school exams also. So let us see how to work out this numerical. It is also there in your book back exercise 10.5. Let me read the problem. So it's an Young's double slit experiment, monochromatic light. So intensity of light at a point on the screen, when the path difference is lambda, that intensity is k units. See, it is given in the problem, when the path difference is lambda, whatever the intensity you get, that you have to assume as k. See, first of all, to find the intensity, you want to know phase difference. But here in this problem, path difference is only given. So you know the formula which connects path difference and phase difference. Let me write it. So 2 pi by lambda into path difference will give you phase difference. So this is the formula which connects phase and path. So where x is the path difference. So 2 pi by lambda is the multiplier which will give you phase difference. So for this given path difference, that is lambda, we have to substitute lambda first of all to know this phase difference. See, I have substituted this path difference value lambda. So lambda goes off. So it's very easy. So phase difference is 2 pi. When the path difference is lambda, the respective phase difference is 2 pi. So you also should know one more formula for resultant intensity when both the intensities are equal. So you know the formula. So I is equal to, so when it has equal intensity, so resultant intensity I is equal to 2 I naught into 1 plus cos phi, or you have the one more equivalent also, 4 I naught into cos square phi by 2. So any one formula, whichever formula you prefer, both are same only. So whichever any of these formula you have to use to find the intensity. See, I have written this I is equal to 2 I naught into 1 plus. So here the phase difference is 2 pi. So cos 2 pi. So cos 2 pi value you know. So cos 2 pi cos 0. So basically 1. So 2 I naught into 1 plus 1. So 4 I naught. So when the question is, when the path difference is lambda, so the respective intensity what we are getting is 4 I naught. But in this question they have given this, we have to take it as k. So for this problem we have to assume this 4 I naught as k. See, now only we are entering into the problem. See, they have given when path difference is lambda by 3. So far we have whatever the input, first input lambda only, we have found out that intensity. Now this is the actual question. So when the path difference is lambda by 3. So same procedure we have to do. So we have to substitute lambda by 3 and respective phase difference we have to find. That respective phase difference you have to substitute in any of these formula to get the intensity. Say I have substituted the path difference is lambda by 3, so 2 pi by lambda into lambda by 3. So I'll get the phase difference. So phase difference is 2 pi by 3. So I have to substitute this phase difference in the formula 2 I naught into 1 plus cos phi, or I can go for 4 I naught into cos square phi by 2. So I am going for this only. So 2 pi by 6, because in denominator 2 is there. So 2 pi by 6, which means pi by 3. So cos pi by 3. So cos 60. So cos 60 will be 1 by 2. Then you have to square. You should not forget to square. So 1 by 2 square will become 1 by 4. So 4 I naught into 1 by 4. So 4 gets cancelled. So I naught. So when the path difference is lambda by 3, so the resultant intensity will be just I naught. But you should not stop here, but you have to express the final answer in k. So we have assumed 4 I naught as k. So when 4 I naught is k, so I naught you have to write it as k by 4. So k by 4 is the answer. So now let us find for the other path difference values also. In this book bag it's only lambda by 3, but in previous years they have just asked for the other path differences also. So let us do a few more also. I have written here lambda by 4, lambda by 3 already we did. So lambda by 2. So lambda by 4 and lambda by 2 we will try now. See, I have made the calculations for lambda by 4. So 2 pi by lambda into lambda by 4, lambda goes off. So pi by 2. So phase difference is pi by 2. Now I have to substitute. So I have taken 2 I naught into 1 plus cos phi. This formula itself I have taken. So you can take any formula. 4 I naught cos square also you can use, or this also you can use. So cos pi by 2. So cos 90. So cos 90 is 0. So 2 I naught is the intensity. So here again you have to express the answer in k. So you know 4 I naught is k. So 2 I naught will be k by 2. See, I have done it for path difference lambda by 2. So 2 pi by lambda by 2. So phase difference is coming as pi. So 2 I naught into 1 plus cos phi. So phi is equal to pi. So cos pi cos 180. So cos 180 you know it is which is minus 1. So here that goes off 1 minus 1 0. So here intensity is coming 0. So when intensity is 0 obviously, so it's k, says you cannot express it in k. The answer is 0 when the path difference is lambda by 2. See, here I have written all values in a table. See, path difference is lambda and respective phase difference is 2 pi, and respective intensity I have written 4 I naught, and lambda by 3 respective phase difference 2 pi by 3 and intensity I naught. So if you take this 4 I naught as k, this has to be k by 4. See, I have written for the other things lambda by 4. So phase difference is coming pi by 2 and respective intensity is 2 I naught or k by 2, and lambda by 2 phase difference is pi and intensity will be 0. See students, this question was asked many times in the previous board, so that's why I feel it's a very important numerical and you should know to work out this problem. It's easy only. So what you have to know is just to convert that path difference into phase difference. Then you have to put that intensity, resultant intensity formula. When intensities are equal, that formula you have to use to get the resultant intensity. So thank you students. So again we will meet with another video, important Cbse numerical I will upload. Thank you. Don't forget to like, subscribe, and also share this video to your friends so that let them also get the benefit. Thank you students.